All right, awkward pause while we tried to figure out who was on next. All right, so I'll introduce myself. So hello. 1 second. There we go. So I'm Grant Skinner. I am the lone non-Adobe representative on stage today. Thank you. Which is an absolute honor. I'm very happy that Adobe trusts me enough to give me the stage. It also means that I don't have a marketing team behind me, so I make my own slides and everything. So, I'm here to talk to you guys today about CreateJS. And CreateJS is a suite of libraries that I and my team, and now the community, have been working on to basically let you build really interactive, rich 2D experiences on the web. And we're going to take a look at the different libraries that CreateJS comprises, so EaselJS, TweenJS, SoundJS, and PreloadJS. We're going to take a look at Zoe briefly, which is an open source tool that we use for building some of the content. And we'll take a look at a couple of other tools that you can also use when creating CreateJS content. So what can you use CreateJS for? Well, quite a few things. You can use it for things like integrated animation, so not necessarily a whole website, but for building out little animations that go into a website. You can use it for things like banner advertising, casual games, infographics, especially interactive infographics, data visualization, and also for things like skinning. So you could actually use this to create little elements that you're going to use inside of, dynamically build these graphics and use them inside of your site. A couple of examples of things that have been built with CreateJS so far. This is a project that my team recently released. It's called Atari Arcade. It's at arcade.atari.com. It's made up of 8 classic Atari games that were rebuilt for the modern web, so using entirely HTML5, and kind of an interesting site to house them all. It was actually just named one of the top 50 websites by Time Magazine, so this gives you an idea of sort of how mature this technology is becoming. Another award-winning site, also built on top of CreateJS, is the Dom Perignon site. They did some really neat motion graphics and transitions using CreateJS, and then they layered DOM content on top of it. So they used HTML for the text content and CreateJS for all the animations. Where can we use it? Well, kind of the obvious places. We can use it on the web. We can use it on mobile. I think this is a really interesting emerging market, embedded. We're starting to see HTML5 being used as a UI layer on top of embedded systems, right, on top of devices. And I think this is really exciting. Obviously, the desktop, you look at Windows 8, for example, and HTML5 has become a full citizen for application development. I think that's really cool as well. Another space I think is worth looking at is e-publishing. We can build out interactive magazines and create little informatics, little pieces that people can interact with. This is a quick example, something that we built a couple of years ago actually using CreateJS. This is embedded into a little magazine piece that talked about Portal 2. And basically it let people play around with some of the dynamics of Portal 2. And they could play this using multi-touch on the iPad while reading the digital version of this article. We have sort of 4 core philosophies behind CreateJS. We want it to be really approachable. And to do this, we've tried to use APIs that are familiar with a lot of interactive developers. A lot of the code looks similar to Flash, for example. So it's quite approachable. We have well-documented API, a lot of examples. We're starting to release tutorials around this as well. We want it to be modular. These are individual libraries within a suite. This isn't one gargantuan library. You can pick and choose which pieces you want to use. With many of the libraries, you can even choose little pieces out of the library and use what makes sense to you. So for example, if all you need is easier vector graphics drawing on top of Canvas, you can just pull out the one class that deals with that and use it without having to worry about incorporating the entire library. We want it to be extensible. This is not a purpose-built library. It's not for building, RPGs or platformer games or anything like that. These are very multi-purpose libraries, and we want people to extend them and build things on top of them. And finally, and I think most importantly, we want it to be very open. So these are MIT licensed. Anyone can use them for pretty much anything they want. We're working very hard to get the community involved, to have people contributing to it. And we're also reaching out to industry leaders to get them involved. So for example, a couple of months ago, Adobe joined us as our first and largest sponsor. And they've been doing a great job helping us promote it and identifying ways to improve it. I'm excited to also announce that this is actually the first time I've talked about it publicly. Microsoft has joined as a sponsor, and they've been really doing a lot of interesting work with it as well. They've been using it, for example, as a framework to teach new programmers how to build things online, which I think is really neat. So let's take a look at the individual libraries that make up CreateJS. This is actually the first one that we built, and what kind of led to the development of this whole suite is EaselJS. And EaselJS is basically a platform for creating 2D graphics. And it's mostly canvas-oriented, but we actually have some interesting things going on around other surfaces as well. Basically, it lets you create and manipulate a display list full of different types of graphics. So bitmaps, text, vector graphics, apply effects to those things, and then interact with them. So we have mouse support, we have full multi-touch, which works both with touch events, so the iOS-style touch events, as well as Microsoft's new pointer events, or MS Pointer. And it's really easy to use. So I'm going to show you a little bit of code just so that you get a sense of how it works, and so you feel like you can go away and build something on your own. So here we have a very simple HTML document. This is actually using Source Code Pro, the font. I actually updated my session this morning when I saw the announcement. I was like, that looks way better than monospace. So basically, simple HTML document. In our body, the only thing that's at all unusual is that we have a canvas with an ID of demo. Up in the head, we are linking to the EaselJS minified library and writing a little bit of script that'll be run when the body loads. You can see it's actually rendering down at the bottom here, but nothing's showing up, right? My text hasn't shown up. And the reason for that is that in CreateJS, or in EaselJS, we actually control when these renders happen. So if I uncomment this and refresh, oh, someone touched my demo. I'm going to have to refresh this way. You can see that it renders in. So all I've done is created a text instance, told it that its text is hello world, what its font is, added it to the stage. That stage is pointing at the canvas, and it's now managing all the display on the canvas. And when the stage is updated, it's going to clear the canvas and render its display list onto the canvas. So pretty simple for static art. What if we want to make it animated? Well, to do animation, we want to change properties over time. So CreateJS comes with a class called ticker. And ticker is basically the heartbeat of whatever we're doing. And so I can add a listener to ticker, and I can define a function called tick. And now every tick, which by default happens 20 times per second, I can have some code run. So I can say stage.update. We're not going to see a difference because obviously we're just redrawing the same content. But I can start changing properties. So I can say, make this move, change its X position. And this is going to start to animate. And of course, we can, mess around a little bit more, change the Y position. And we'll make this kind of fun. And, bouncy text. And just for the fun of it, why don't we also change the color? So we're going to say CreateJS.graphics.getHSL, and we're going to say a random hue and oops. And now if we run that, we get wonderful blinking text. One other kind of neat little thing is that we can actually control when the stage gets cleared as well. So we don't necessarily need to have it clear every single frame, every single tick. We could have it retain our graphics over time. So we can do sort of generative stuff as well. So that's sort of a quick hello world. Obviously, we have different types of graphic objects, right? We have labels, which we just looked at. We have vector art, so we have shape. And basically, we just create a shape, grab its graphics, and start drawing. And this is all retained graphics. We can add bitmaps. And then we can also aggregate these things together into containers, so we can move them around together. And so here I've created this beautiful graphic, which has the bitmap daisy, the text daisy at the bottom, and then a vector round rectangle around it. And so I want to animate this and make it sort of spin around. So the other way that I could do this is I can tie into the onTick event that's inside of every single display list, or every single display object, which is kind of similar to an onEnter frame if you've ever done Flash. And I can say item.onTick equals a function. And all I want to do is say every frame, let's update skew x. We'll just do plus equals 5. So now we get that. Maybe we'll do skew y also. So now we get this. But I don't really like how it's sort of flipping around that top left corner. So I can reach into my item here, and I can change where its center point is by setting a registration X and registration Y. And so now this is going to flip around just like this. So this is just a quick introduction to some of the different elements that you use in building EaselJS content. Now, a big part of just about any online casual game or a lot of different experiences is sprite sheets. So we want to make it really easy to work with them. And so we have two classes that deal with sprite sheets. We have the actual sprite sheet class, which defines the data for a sprite sheet. So here you can see that it's defining the images that are going to be used. It supports multi-image sprite sheets. It defines how the different frames are found, and these can either all be the same size or they can be defined as separate, different sized frames. And it defines the animations. So it basically says the run animation spans from 0 to 3, inclusive, and when it finishes, it's going to go back and play run again. Likewise, explode is frames 4 to 10, and when it's done, it will also go back to run. So I want to make my pig explode when I click him. So I'm going to add an onClick handler. And all I'm going to do is say this.goTo and play. And we'll refresh. And now when I click my pig, oh, bacon explosion. But that's kind of, the timing doesn't seem right? He's running kind of fast. I want to slow this down a little bit. And I'd also like that explosion to be a lot more dramatic. So I can tell it to only play these frames every second tick, or in the case of the explosion, I'm going to tell it to play play a new frame every 10 ticks. So now you can see that the pig is running a little bit more slowly, and when I click it, we get this very dramatic explosion. And so this mouse interaction isn't free. Canvas, by default, only knows about the pixels on it. It doesn't have any concept of objects. And so EaselJS actually wraps that all for you and gives you pixel-accurate interaction with both mouse and touch. So we mainly target Canvas with EaselJS, but obviously there's a lot of different graphic surfaces we could be using, right? We have Canvas, we have the document object model, SVG, and WebGL. And we want to be able to incorporate each of these to do things that they're great at. So for example, this is a game that we built a while ago. All of the Chrome, including the characters down at the bottom, the on and about buttons up at the top, these are all DOM elements. They're all managed through jQuery. Likewise, the little health bubbles that you can see, those are also all DOM elements, whereas the whole game engine is written in EaselJS and uses the canvas. And we want to make these types of interactions very easy. And so we have this special display object called DOM element, and basically allows you to incorporate any element from the HTML DOM into an EaselJS display list. So in this case, we have our friendly space pig, and we can move him back and forth, and he can actually have this speech bubble, and you can see the edge of the canvas when he hits it, but the div that actually contains the text can extend out past that. And it can also have, HTML features that really don't work that well inside of Canvas. So this lets us incorporate both, stuff around our canvas and also stuff that's sort of integrated within our canvas. So we're not just limited to what Canvas can do well. We can actually bring in other surfaces. We've recently released a set of experimental renderers for EaselJS that lets us get outside of Canvas. It lets us build the same type of content inside of EaselJS, but actually render it out to other surfaces. So this is running inside of Canvas 2D. This is the exact same content. All I've done is changed a single line of code to tell it to use a different renderer. This is now running inside of the DOM. You can see I can actually drag these images out of this animation. And also as an example, this is now running inside of WebGL. And so we're able to write the same content, and then depending on what our deploy target is, we can choose which surface to use. Second library is TweenJS. It's a nice little library for doing tweened animations. Very simple to work with, but it also has a lot of interesting power. So here I'm setting up a little circle that I'm calling ball, and a label, which obviously has the text bounce. And I'm going to get a new tween targeted at ball. This is going to move ball down to a Y position of 200 over 2 seconds, 2,000 milliseconds, and it's going to use a bounce ease. And so if I run this, very simple. But where TweenJS gets really interesting is when we start using its ability to chain these actions together. So here what I'm going to do is I'm going to run that bounce, then I'm going to change the text of my text field to wait. Then I'm going to wait for a second, fade out the ball, again changing the text, then change the text again, wait another 500 milliseconds, and then I'm going to call the alert function on window and pass it all done. So if I run that, we get this nice sequence of events that's really easy to code up. There's a lot of features that are a little bit more powerful. We can actually sequence different tweens together, so individual tweens can call each other. Obviously, we can deal with non-numeric props. These tweens are completely deterministic, which means that you can jump to any point within the tween. So you can say, go to this point in the tween, and it will always render exactly the same, so that you'll get the same output. And we also have a plugin model, which is kind of neat. TweenJS doesn't understand CSS, for example. It likes to work with numeric properties, but we do ship it with a CSS plugin that when you install it, it can actually work with things like pixel values. It knows how to append strings that are needed to work with CSS. So you can really extend this to do what you need it to do. Pardon me. Sound on the web is really difficult right now. It's probably the biggest challenge building this type of content. We have HTML audio, the audio tag. We have, obviously, Flash as an option. We have web audio, which is an emerging standard. And most of these have inherent problems. And so we really needed a way that we could abstract these things out and make it easy for us to work with audio. So SoundJS basically lets you choose how you want to play your audio. So you could say, I want you to start out trying to use web audio. Then I want you to fall back to HTML audio. And if you don't have that, fall back on Flash. And you don't need to worry about it past there. The SoundJS will choose the appropriate plugin. You can query it for capabilities based on the plugin that it chose. And you can do things like set global volume. When you actually play a sound, you get back a sound instance, and you can work with it, changing its volume, changing its pan, listening for when it completes, stopping it, pausing it, all the things that you would expect. But you no longer have to worry about whether that sound is playing through a tag, or whether it's playing through web audio, or whether it's fallen back on Flash. All of those details are hidden from you. So just to show that that works, I'm going to play some really annoying audio. Reporting aboard! So, not the most exciting demo, but we have audio working on the web, which is harder than it sounds. The final library that I want to talk to you about is PreloadJS. All these other libraries have, sort of an obvious use, right? We're visualizing things, we're animating things, we're hearing things. But in order to build a great experience, we also need to be able to load all the assets that are going to be used. And we have a couple of options for how we do that on the open web. We can use tags, or we can use XHR2. But XHR2 support is still somewhat limited across modern browsers, and it's a little bit broken in some browsers. So what we do is, just like SoundJS, we abstract all of this away for you, and we basically let you create these queues. So you can have multiple queues, and you can load content, and by default, we'll try to use XHR2 and give you full progress events, so full granular progress. But if we can't use XHR2 because it's not supported, then we'll fall back onto tag loading and give you sort of smooth progress events. We'll sort of fake it a little bit for you. And you can either load files individually, or you can load in JSON manifests or create manifests in your JavaScript code, and the queue will manage that whole thing for you. It's also kind of nice because it can work as an asset management tool. So once you've done all of your loading, you can actually go back and request results from PreloadJS and pull your assets out from all over your project and get what you need. You can deal with files individually as they load. You can register plugins, so you can actually say, as sounds load, for example, I want SoundJS to take care of them. Or likewise, you could say, well, I'm actually going to be loading sounds through Flash, and I know that you don't know how to handle that directly, so I'm going to register a plugin that will handle that for you, but you can aggregate the progress. I'll tell you how those loads are going. And finally, you can disable XHR completely. This is handy, for example, when you're doing local testing, because a lot of browsers don't work well with XHR when you're running local content. So all this is great for developers, right? You can code something up, you can share it with people, but I think to create really great content, you need great tools. And this is something that my company's been struggling with for a couple of years. We taught ourselves how to do JavaScript from a large Flash background. We started building these projects, and we really didn't have a great workflow for how we got awesome graphical content into the projects, or how we got our designers involved in a really meaningful way, other than preparing comps and having us try and retranslate it. So sprite sheets are often a really big part of any project, and we have a few different options that you can use to create sprite sheets that'll work with EaselJS. We have our open source Air application called Zoe, and it'll basically consume an SWF and let you generate out sprite sheets from it. It has some kind of interesting features, like it'll do multi-image sprite sheets. So if all your sprites don't fit on a single image, it'll actually create multiple images. This is great for mobile, because on mobile we have a fairly limited texture size that we can work with. It also does what we call threshold reuse. So you can basically say, if any two frames are similar enough, just use the same frame, like reuse that frame. And that lets us really reduce the size of our sprite sheets often, right? Because our animator will have little teeny tiny differences between different frames on the same timeline, and we can basically cull those off very carefully. Flash Pro CS6 has built-in sprite sheet creation tools, nicely integrated. You can right-click on symbols and say that you want to generate a sprite sheet from it, and it has built-in support for exporting EaselJS data. And finally, Texture Packer also supports EaselJS, although to date they have insisted on calling it EasyJS, but we're working on that. Another tool that we've been working on with Adobe is something called Toolkit for CreateJS. And this is a free extension to Flash Pro CS6. And basically what it allows you to do is publish FLAs out as HTML5. Now, this isn't an exporter. This isn't like Wallaby, for example. What this is a new workflow that you can use to target HTML5. You're not going to take an old FLA with a bunch of interactivity and stuff written in ActionScript and run this through it and get out a working HTML5 project. What this is for prepping visual assets to use inside of CreateJS projects. And it's fairly robust. We support most types of content. We support tweens, easing, some effects. But I think the most important thing, we actually even support, you can actually write JavaScript in a special format inside of the timeline. But I think the most important thing is that we write extremely readable code. We've probably put more effort into the code output, like the formatting of the code, than into actually getting that code to generate. We really want it to be both something that generates great code that you can use, and also something that you can use as a reference, so you can look at it and understand how CreateJS works. Finally, it also has a really great designer-developer workflow. Basically, the designer can completely own the FLA. They can generate previews. They can see how it works. And we create a library JavaScript file full of instantiable symbols that, as a developer, you can just pull in and say, you know, new dinosaur, and get that asset and be able to put it on stage. I'm going to show you a really quick demo using this. So this is an animation that my Illustrator put together. You can see that it just does all of this. And you know, we can publish it out as a SWF. But we can also use Toolkit for CreateJS. So this is the panel here. And all I do is I hit publish. And this is going to generate the JavaScript and a preview HTML file. And this is now all inside of HTML5. And this is still vector content. This hasn't been turned into a sprite sheet or anything like that. This is completely, we can completely manipulate this. It's actually retained my timeline, so I can say, you know, go to and play fire, go to and play right, go to and play left, and it will work just as you would expect. So that asset now becomes something that I can pull into any project and just have it work. I'm really happy to announce that version 1.1 of Toolkit will be coming out probably, according to the tweets I'm seeing, probably tomorrow. We've done a lot of work on it. It's actually a full re-architecture. It runs much faster, exports a lot more quickly. We've added support for masks. We've added support for shape tweens. And you know, lots of other little things. But one of the things I find really interesting is multi-frame bounds. And this is a sort of minor feature, but it enables something that's really important to me. I think one of the things that frustrates me about a lot of these experiences on the web right now is that they're huge. They'll be like, you know, 10 megabytes for a game. And I come from a Flash background. I love the day of being able to build a cool game in 100K or 200K. And I'm still looking for ways to enable this. And one of the ways that we've done this is with runtime sprite sheets. So displaying this content as pure vector can be kind of slow, especially on a mobile device, where sprite sheets perform really well. So what I wanted to do is find a way that we could have the best of both worlds. And so we created, in the most recent version of CreateJS, a class called Sprite Sheet Builder. And Sprite Sheet Builder can take any content, but in particular, it works well with movie clips exported from Toolkit. And we can basically just say, I want to create a new sprite sheet. I want it to be based on my Gunnertron animation, which is the animation you just saw. I want to scale this out at 0.5, so half scale, and I can change this depending on what my target is. On a phone, I might make it smaller than on a tablet, for example. And then I want to build this asynchronously, so I can actually do this while other things are loading. And it's going to do this. It's going to take that movie clip, it's going to generate a whole sprite sheet for me, and then I can use that sprite sheet in my bitmap animation, just as though it were the original source. And so I'm going to get great performance using the sprite sheet, and I'm going to save a ton of file size. So in this specific example, the sprite sheet, if I had pre-prepared it, if I had at half scale, it would be 2.5 megabytes. If I really tweaked it and used something like image alpha, I might get it down to closer to a meg. But the Gunnertron.js, the JavaScript library that is exported from Toolkit over the wire, because most things on the web, most text over the wire travels as zip, it's 19K, right? Which conveniently is the identical size as the original Swift. So we're back down to where we were with Flash, which I think is a huge deal. That pretty much wraps me up. If you're interested in learning more, check out createjs.com, and thank you very much.